Okay, I wanted to do one last problem where I made a buffer, but this time I made it using a base. And I know you guys are uncomfortable with the amine bases, but you know the bases that have the NH2, which is called amine. But that's why I wanted to show you. So I see the OH here, and I know you guys are going to want that to dissociate, but it doesn't. Remember, we don't care about the chlorine because it is in column 17, so we don't care about columns 1, 2, or chlorine, bromine, or iodine because they come from strong acids and bases. So that means that I'm left with HONH3+. And if you remember from class, if there's a plus, that must be the acid because it's ready to donate the H, and if there's no plus, then that's the base. So what I get from this reaction is right there. Okay, so this is 0.100 molar, and this is 0.100 molar. Okay, and now what I want to do in problem number 28, it says, why don't you add 0.02 molar HCl? So I again look and I say, hey, there's no HCl. And I have to decide which side to put the H plus on. Now, I could put it over here. If I put it over here, the H plus would react with OH to make water, which would be great, except for there is no OH in the beaker. Okay, so if I put it over here, the H plus can react with the HONH2 to make more of this. That makes sense. Okay, so the H plus does not go on this side in this problem. It has to go on the opposite side. An easier way, if this is confusing to you, if you already see OH, put H plus on the opposite side. Just trust me on it. Okay? So we added 0.02, and it's in a 1 liter solution, so molarity is the same as moles. And I can see already that this one is going to run out first. And that would give me, when I subtracted that, sorry, let me find my key. Now let's think, where is it going to add to? Is it going to make any OH? No, it's going to make more of this ion. So it's going to be 0.02. Okay, and that's going to make this 0.12. Okay, we divide again by liters, and now I'm ready to ice. We have 0.08 and we have 0.120, and you have two options here. Okay, you can either say it's going to dissociate and give me more, let's see, it would minus x from here, plus x from here, and plus x there. Okay, you could do that, and that's going to be how you would find your hydroxide. Or you can say this one's going to minus x, this one's going to plus x, and that's going to give you H plus ion. So what I'm going to do is I'm going to say, well, it doesn't really matter which one we do. So let's just say we lose x here because this is the way we're used to doing it, plus x and plus x. Okay, and that gives me 0.08, 0.120, and x. And then from there I would need to use the Kb because I have the base, x times, and then we neglect because 5%. X times 0.120 over 0.08, and we solve for x, and when we solve for x, I don't have my calculator here, guys, so I can't do it for you, but you would get the amount of OH, and to find the pH, you'd have to take the 14 minus the POH. Okay, when you do this, I do know the answer to this should be about 6.64. Okay, oops. Alright, thanks guys.